Hello and welcome to another Fizz Wallops Science Refreshers. Fizz Wallop here with another Science Refresher. Hope everyone's well today and is doing well in life. And there'll be a wee joke or two at the end maybe. I always like to leave you with a wee joke. This video is about the chemistry of carbon. I'm going to go into, if I remember correctly, it's called empirical formulas. A wee bit. You'll get my meaning as I go along. I'll take you over to my workspace and we'll begin. Okay, the chemistry of carbon. The chemistry of carbon. What do you need to know about it? I made one about tetravalency, which means carbon forms bonds with 4 elements on the periodic table, or compounds of elements on the periodic table at the same time. And that's carbon. C, and the wee lines above and to the side represent its potential bonding, covalent bonding. It's tetravalent and it's a covalent element. That means it forms strong covalent bonds with other elements and compounds. Right, organic chemistry. Right. In inorganic chemistry, you have alkenes, alkanes and alkynes. I'll tell you about them. Alkanes have the empirical formula C, which is carbon, N, the letter small n, H, which is hydrogen, 2 times N, 2N, plus 2. Okay? What that means is, I'll take you a bit closer. Sorry, have a puff in my cigarette. Take you a bit closer. CN H2N plus 2. What that means is for alkanes it's like methane would be CH4, which is C1H2 times 1 plus 2. So CH4. That's how you work it out. CH4 C1H2 times 1 plus 2. N is an integer and it's a constant in the equation. It balances out. Right. Hello everyone. Sorry you can't see me. Hope you're enjoying the video so far. I'll just grab another sheet for writing more about organic chemistry. Did you hear? I knew a brilliant chemist once. Her name is Molly Hughes. Molly Hughes. Oh, she's amazing. Lovely person. Oh, wait a minute. Fantastic, fantastic. Oh, sorry about the delay, folks. Yes. Stand that there. I'll go through the seconds and I'll go on a bit further about the chemistry of carbon. Oops, do that a bit too much. Right, just be a second. Right, now that was alkanes, that's CN, H2N plus 2. N is the number of atoms bonded to carbon based on the number of carbon atoms present in the molecule. Okay? Right. Now alkenes. There's alkanes like methane, ethane, propane and butane. I'll go in a bit more detail about that later. And there's alkynes. Alkanes, alkenes and alkynes. Now an example of an alkene. Ethene, ethene, E-T-H-E-N-E. Just like model walk again, sorry folks. Alkenes, like ethene, have the formula C2N, no, sorry, I'm getting a bit distracted, I'm a bit tired. C2H2N, and that means the formula for ethene is C2H4, no, that's not right. Plus one. Alright? C2H4. No. Oh, I'm getting a bit mixed up here. Sorry, I'm just tired, everyone. CN H2N minus 1, that's H2N C2H2N that would be ethane, Yeah, I'm right. H5, C2H5. Okay. No, that's not right. Well, we'll review alkanes and I'll get back to you on alkenes and alkynes. I'm getting a bit mixed up because I'm tired. I was up all night and all day yesterday. My apologies. So, to review, alkanes are like methane and ethane and so forth. Methane is C1H2 times 1 plus 2 plus 2. So that would be CH2 plus 2 H's is CH4. That's methane. And you get like ethane, propane, butane, and on and on. All you do for as you go down the list, ethane, propane, butane, right up to nonane and decane and that, you just you increase the one after the C by another number, by another one. You add another one on it and you change the formula accordingly. So it'd be, for say butane, it'd be C4H8 plus 2. So that would be C4H10 for butane. Right, Right, I'll show you that a bit closer. Sorry for the delay, everyone. Right, you get ethane, propane and butane follow methane. That's methane. That's methane. CH4, which is C1H2 times 1 plus 2 H's. So you get C1 and H4 for methane. Ethane's C2H2 times 1 times 2, sorry. C1H2 times 2. Sorry, I'm just tired. God, I've had a busy couple of days. You wouldn't believe it. Right, I'll draw ethane. Where would I put my pen? There we go. Right. Ethane is C2H2 times 2. Remember, that would be N. That's that second 2 after the H plus 2. So ethane is C2H4 plus 2. So that would be C2H6. That's ethane. Butane, propane, there's butane, it's C4H8 plus 2, C4H10. That C4H10 is butane. You just multiply the digit after the carbon, which is the number of carbons in the molecule, by you multiply the H2 in the formula by 2, which is N. Back to the formula. Cn, which is the number of carbon atoms in the molecule, plus H2 times N, which is the number of hydrogens in the molecule. N is the same number as the number of N after the carbon, the C. So you've got CnH2n plus 2 for alkanes, for methane and ethane and propane and butane. And as you go down the list of them, you just add another digit, another number 1 to the N after the C. So you've got, like butane, C4H8 plus 2, which is C4H10. That C4H10 is the empirical formula for butane, which you get in butane gas. Just put you back on the computer screen. There we go. Oh, sorry. There we go. Hope everyone enjoyed that video. I'll do another one covering alkenes, which is a slight variation to the basic empirical formula of the carbon compound. I need to review that because I'm a bit tired at the moment. My brain cells only firing properly. Being busy. I suffered a brain drain once. Here's a wee joke for you. I suffered a brain drain once. My brain got washed. It got washed right down the drain. It was stormy. Everyone look after themselves and take care. All the best. Hope you enjoyed my wee video. Thanks. This is Professor Fizzbang Wallops signing off. Take care. Look after yourselves.